So, we're diving into a really big question today. How do you make a super powerful AI actually follow our rules? And it's way trickier than it sounds, because the rules we humans use are all about nuance, context, and shared experience. Stuff a machine just doesn't get.
I mean, it really all comes down to this, doesn't it? It sounds so simple. When we tell another person to be good or act ethically, we're tapping into this huge, shared library of culture, morality, and unspoken agreements. And AI has none of that. It just has lines of code.
And this right here, this is where the rubber meets the road. If you're a human on a company's board, you know what act in the company's best interest means. It's a complex blend of short-term goals, long-term vision, ethics, you get it. But for an AI, that phrase is basically gibberish. What does best even mean? Which data should it look at? What is it allowed to do? That gap right there is the whole challenge.
So yeah, we're calling this the AI translation problem. It's this massive challenge of turning our big, squishy human ideas into literal black and white instructions that a machine can actually execute. But here's the wild part. This isn't some new 21st century problem. People have been dreaming about this for centuries.
Now, seriously, we're talking way back in the 1600s. This philosopher Leibniz had this dream of creating a kind of universal math for the law. He imagined you could just plug a legal dispute into a formula and calculate the right answer with no human bias. Well, fast forward a few hundred years, and that's pretty much exactly the dream and the headache that computer scientists are wrestling with right now.
Okay, so how in the world do we start to solve this translation problem? Well, it turns out there's a pretty good blueprint for us to follow, and it comes from a technology we're all watching very closely: self-driving cars. They've been chipping away at this for years. The folks in the auto industry have this absolutely critical concept they use called the Operational Design Domain, or ODD for short. The best way to think about it is as the AI's comfort zone. It's not about everywhere the car could go, it's about the very specific, predefined conditions where it's been designed, tested, and proven to be safe. And here's what that looks like in the real world. A car's ODD might say, "Yep, I'm good to go in sunny weather on a highway with clear lane markings." But it also clearly says, "Nope, I'm not designed for heavy snow or dirt roads or a chaotic construction zone." The whole point is that the AI isn't supposed to be a master of everything. It's a specialist, trained for a specific job in a specific environment.
And this is the most important takeaway. The promise of safety isn't a blanket guarantee. It's really more of a contract. The car company is saying our AI is safe if and only if it stays inside its ODD. The second it drifts outside those boundaries, all bets are off, and the system is designed to hand control right back to the human driver. That idea is going to be key.
All right, so let's take that core idea, the ODD, and let's make a big jump. Let's leave the world of physical roads behind and step into the high-stakes, abstract world of a corporate boardroom. It's a really interesting question to think about, right? For a self-driving car, the road is obvious. It's made of asphalt and paint. But what's the road for an AI that's supposed to be making huge strategic decisions for a billion-dollar company? What world is it navigating?
Well, its road is the entire landscape of corporate governance, and that is an incredibly complex, tangled web of federal laws, international regulations, shareholder agreements, ethical guidelines, and internal company policies. And honestly, just like an unpaved road in a blizzard, this environment is just packed with hidden risks and ambiguities for an AI that isn't prepared.
Okay, so this brings us right to the core solution from the research paper we're exploring today. If a corporate AI needs its own, super well-defined operational domain to be safe, how do you actually build one for it? The answer, it turns out, is to create a kind of bilingual rulebook.
The big idea is to literally create two parallel versions of every single corporate policy. You have one version for the humans, written in our normal, everyday language that's based on principles. And then you have a second, parallel version, written just for the AI, in precise, logical, machine-readable language. It's a lot like an international business contract that has English on one side of the page and Japanese on the other, with each clause mapping directly to its counterpart.
And here you can see exactly how that translation works. So the big, fuzzy human principle of fair treatment becomes a very specific command for the AI. Run all data through these 5 pre-approved non-discrimination tests. The goal to monitor performance becomes a hard and fast rule. Start a continuous audit on any transaction over $10,000. Every vague human idea gets a concrete, measurable, and totally auditable task for the machine.
So you can see the process is really clear. You start with the big human idea, like be fair. Then you get super specific.
What are the exact metrics we'll use to measure fairness? Third, you lock it down. What are the only data sources the AI is allowed to look at to make this decision? And finally, you program the precise action and tell it exactly how and when to report back. You're taking all the guesswork out of it.
Okay, this brings us to the real aha moment of this whole explainer. When we create these incredibly detailed, machine-readable rulebooks, what are we really doing? We're not just writing down policies, we are fundamentally rethinking the whole environment that AI operates in. And this quote just nails it. Maybe we've all been thinking about AI the wrong way. We see it as a car that we need to teach how to drive on our messy, chaotic human roads. But the author here argues that a powerful AI isn't a car at all. It's a train. It's incredibly fast, incredibly powerful, but it's only safe and effective when it's running on its own dedicated infrastructure, its own tracks.
And you know what? This isn't just a clever metaphor, it's completely backed up by the data. I mean, look at this chart. The fatality risk per mile traveled in a car is just astronomically higher than it is for rail or air travel. And what's wild is that trains and planes are way more powerful and faster, but their dedicated infrastructure makes them far, far safer.
The reason for that amazing safety record is, well, it's really simple. It's the dedicated infrastructure. Trains run on tracks. Planes fly in controlled air quarters. They operate in their own special, purpose-built environments, which removes all the chaos and unpredictability you get on an open, public road. And that brings us right back around. That bilingual rulebook we've been talking about with all its specific machine-readable policies, that's not just a list of rules. That is the railroad. Those policies are the dedicated tracks that allow a corporate AI to operate with incredible speed and power while keeping it safely within a predictable, controlled, and auditable environment.
So this leaves us with one last, pretty fascinating thing to think about. As more and more companies start meticulously building these railroads for their AIs, translating human principles into rigid computational rules, they're not just managing a new tool. They are, piece by piece, creating a brand new kind of computational law. So the question is, in building these railroads for their machines, are they also, maybe without even realizing it, building the legal framework of the future?